Hi, I'm Kapil. Recently, a friend of mine asked me, how can a AI model generate an image? It's surprising. And that too, how can it generate an image that is not part of the training data? It's like a new thing getting created, which did not existed in the inputs. Let's dive in 10,000 feet view into three perspectives of the image generative AI. Before we dive in, some background. Left side is an image of a dog. You can view it as an image pixel space where each dot is a pixel in that format. Now, this, when passes through the encoder, gets converted to the latent space. We'll talk about it in a minute. Latent space, decoder takes it as an input and can convert it back to the image space. So, recapping, encoder converts image space to the latent space, and decoder is converting latent space back to the image space. Now, what is really the latent space? It is a different kind of a representation. Just for understanding purposes, let's take it as it's not a pixel wise thing, but it is the feature wise. So it is extracting the features of the dog and of the surrounding ambience. It's looking into how the eyes look like, what is the color, what's the color of the skin, and what's the distribution, what's the texture, how the ears looks like, and so on and so forth. So you can view the latent space as a kind of something that is keeping the information in terms of the features. We need to still dive in a little bit more into the latent space. So this is the, let's say, the data set of several handwritten numericals from 0 to 9. And let's say this becomes the total data set, which is fed to the decoder encoder that we talked about in the last file. So this image space data set, when it gets converted into the latent space, let's just for visualization, let's see how one of the latent space could look like. In this here, it's a 2D representation of how that latent space could look like. Here, each cluster is reflecting one particular number. So let's say in here, this color, this zone is what is reflecting a number 7. So if I put a mouse here, this one point may be corresponding to this image sample. But if I move from here to here, this point may very well be corresponding to this 7. All in all, when I'm moving in this space, I'm actually browsing or hopping between the various handwritings of 7. Let's see the traversing of this in the latent space a little bit. One more example. So this is, let's say, the latent space. Let's just focus that
It's
all the
one
latent
o'clock.
space is uh, the for the cats. If I'm on this side of the latent space, the images that are corresponding here, the cats are of black color. But as I move in the latent space, these points in the latent space are corresponding to the cats which are white in color. Similarly, in the other dimension, it could be the pencil drawing versus the oil painting. As I traverse here in the latent space, images are more and more looking like an oil painting. But as I traverse here in this side, they look more like a pencil drawing. So it is this well-formed continuous latent space that forms the basis of the generation of the capability of the images. Coming to the perspective one. These novel images are actually coming emerging from traversing the continuous feature space that we just saw. This is one of the perspective to view. Let's see it more in detail, a little bit more graphically. So this is the latent space. This is the decoder, which is in a way generating the image space things. So when we move in a one particular way in the latent space, what it could be doing is effectively post decoder, the images would be showing a spectrum of young to old. If you move it in a different direction, in different dimension in the latent space, It could be showing a spectrum of no smile to smile and eyes closed to eyes open, for example. So what we see is the latent space is actually serving as a creative playground, this space, where you are, which is very conveniently allowing the manipulation of the features. And this is what leads to the generative capability of images by the model. One of the questions that we asked was that for the how does it generate the images that have not even been given as an input to it? Let's try to visualize that with a simple example. So let's see, this triangle, this circle, this triangle, and this rectangle were the part of the training, let's say. So these 4 points in the latent space were set during the training. Now, once the model is trained, now we are generating, or if we traverse in the latent space, and let's say we position ourselves here, this point may be influenced by whatever are the nearby points generated. And in this case, you see, in this example, this red dot is kind of being inferred by the decoder as a rectangle, but not with the sharp edges. So you can see that it is kind of getting an inspiration of rectangleness from this nearby neighbor, and it is getting an influence of the circle in terms of the edges slowly getting uh, circular kind. So it is this thing as a simplistic example to explain how a new kind of image gets generated when it was not even an input, not a part of the input training space. So coherency is the latent space is what brings the generalization capability. And actually the ability to, in a controlled way, traverse in the latent space is what is the key to any successful text to image generation part. Let's see one more example. Let's say this point corresponds in the latent space corresponds to this chair, and this point in the latent space corresponds to this chair. What this animation is showing, in between of these 2 points, a continuous spectrum as this moves on, how that latent space point look like. So the feature manipulation movement in the latent space is what is generating the images. Let's move to the perspective 2. Another way to view the generative AI model is that these models are kind of the advanced decompressors. And the whole intelligence, the way it is built in, is in the form of a compression in that space. Let's dive in. Let's say we have a JPEG. What does JPEG do? It compresses the image. And then when we have to view the compressed format, the decoder of the JPEG reconstructs it back into the pixel space. Now its compression looks something like this, that of possibly 5 megabyte worth of the data, JPEG might be able to compress it to 0.5 megabyte with a very, very slight loss. Now, if we want to view the whole generative AI as a compression of all the possible images that could be there, uh, whatever is trained, let's to start with, is so lakhs and lakhs of images are compressed in form of their features or whatever, and whatever is the model size in terms of the parameters, that is the whole weights which is containing all the information uh, of the trained data and more. Let's dive in a little bit more. So let's say there's a pixel, there's an image with a 512 cross 512 pixel resolution, and 3 is for the RGB. The total, assuming that one pixel has no relation with the other, each bit can be randomly any value, then the total image space theoretically would be this, where each pixel is represented by 8 bits, values from 0 to 255. Since it's RGB, 3 comes in, and this. Now, this is a huge space. But what happens is that the natural images actually have high pixel to pixel correlation. And this is the key part, key premise for the compression ability. So what happens is, because of this high correlation, you imagine that this space is vastly empty. You can see equivalent of that in the universe, you're spanning around, and though there are stars, but between them distance is there kind of. It's not a very good example, but just for understanding. Now, this correlation and this vast emptiness and the discontinuity, unwalkability in this space leads to that have an opportunity to have the similar amount of information in the lower dimensional space. And this is what the various AI models are doing. They are effectively running at a much lower dimensionality. So what decoder does is it not only reconstructs back, but it also creates a new plausible data, because the way it is storing the things, it's not having the full pixel information. It's just trying to kind of getting a pattern on that, the features kind of a thing. And thus it has a capacity to generate this thing. Now, if you see that the recent models are in the range of 500 million to 10 billion parameters, assuming each of them is FP16 data type, that would lead to a 20, let's say 10 billion into 16, which is 2 bytes, that much worth of the data of the model size. But this data size model, along with some computation every time you need to do, is able to generate megabytes and terabytes of data of the images it can generate. That's the compression that you can view it as. So it is this discompression is generating the plausible data into the things. Let's get into the third perspective. And actually, this is the superset of it, everything. Generative AI, the whole decoder that we do can be viewed as a probabilistic function. And what this probabilistic function is doing is harnessing the power of the data patterns. Let's dive. So one of the ways image can be actually viewed as a joint probability distribution. What I mean is each pixel is not really random in a natural space. That means there can be a joint probability where each of xi is representing each pixel. So joint probability means you are together seeing what is a possible distribution that could be there. And it says holding the relations and the patterns and the textures and the semantics presents in the natural, it's able to capture that. Now let's come back to that encoder and decoder. So the image, we are viewing it as a px probability distribution. When we convert it to the latent distribution, we are seeing it as another kind of a probability distribution. And then the decoder converts it back to the generated image. How the encoder looks like is a conditional probability function q, which generates z given x. Similarly, the decoder is the conditional probability of generating x given z dash. So actually it is this function which is generating the image. This is the generative part of it. And its values and things were generated during the training, the capability. The decoder gets defined during training, and then it is becoming capable to generate the images. Various architectures, whether it's VIE, GANs, or the diffusions, are nothing but the different probabilistic functions. The latent space may look different. The way that within that it traverses is a different, and it gets the capability to discover the pattern and generate from those patterns is what the probabilistic functions are able to achieve. Now, so far we just talked to the images, but the probabilistic computing, it doesn't need to limit itself. It doesn't limit itself to the images. It can apply to any data with the patterns. Could apply to audio, apply to the text as well, apply to the video, obviously, the financials, the financial data, the weather related analysis, or the genomic analysis. So these are the three high level 10,000 feet view perspectives to view the generative AI things. Thank you.